Hi, third graders. You spent the last couple weeks working on multiplication and division. This week, we're going to take what we've learned with that and connect it back to solving story problems. There's 2 learning targets today. We are going to be working on solving story problems with multiplication and division. And we're going to be writing equations that match the problem with a symbol where the unknown number is in the story problem. We're going to call those equations plan equations because they match the story and they give you a plan of what to do. Plan equations can help in a lot of ways. They help you know what's going on and make sure you're on the right track. It helps you picture what kind of operation do you need to do. Does this seem like an adding situation or subtracting or multiplying or dividing? Or is this story problem where you have to do both? Maybe you start with one and then do a different operation. Plan equations can also help you estimate the answer. For example, if your plan equation was 2 plus 2 equals z, you know that z probably isn't going to be 1 because that wouldn't make any sense. So, as we solve story problems, I'm going to have a poster available for you to use to make sure that you're writing strong answers. Let me show you that poster right now. Start with your plan equation. This equation matches what's going on in the story. The equation has a box or alphabet letter that stands for the missing information in the story problem. Show your thinking step by step. Make sure someone else could figure out your strategy just by looking at your paper. You can use diagrams, numbers, and/or words to explain your thinking. If you make a diagram, be sure to label it so that everyone knows what the parts mean. Use neat handwriting. People can't understand your thinking if they can't read your work. To make sure we're all on the same page with what story problems need to have good, strong answers, let's do a really quick practice one. So, I bought Frumpkin a box of Fuzzy Mice cat toys. There were 12 cat toys in the box. And we got them out and made a little pile and she was playing with them. But she has a habit of hiding her fuzzy mice underneath the couch so that the other cat can't play with them. When I came back later, there was only 5 mice left on the living room floor. How many did she hide under the couch while I was gone? All right, so let's solve that one quickly using the list of things that a good story problem answer needs to have. The first thing a good story problem answer needs is that plan equation, the equation that matches the story. So, at the beginning, there were 12 cat toys in the box, and then Frumpkin hid some of them under the couch. She was taking them away from what else was going on. That means we have a subtraction situation. Now, I did a box because that's my habit, but you could have used an alphabet letter there instead. We could have said 12 minus C for cat toys. Some of the cat toys went under the couch. Then at the end of the story, I came back into the room and there were only 5 toys left on the floor. All right, now that we have our plan equation, we can solve this one step by step, showing our thinking. Let's see. If there were 12 and I needed to get to 5, 12 toys at the beginning and 5 at the end, I could subtract back until I got there. Let's take away 2 to get to a 10 and then subtract 5 to get to the 5. So altogether, Frumpkin must have taken 2 toys and 5 toys under the couch. That's 7 toys altogether. So, C, our mystery number, is 7. Before we go on, let's double check that I did everything I was supposed to using that Writing Good Story Problem Answers poster. Basically, we're going to look at this like a teacher for a second. Okay, did I write a plan equation? Yes. Did I show my thinking step by step? Yes, I did, right there. Did I use diagrams, numbers, and/or words? I used numbers. And I used neat handwriting. The only thing I could do to make this answer even stronger would be to label. I should put a label on my answer. C equals 7 cat toys. So now let's talk about division problems. As I mentioned in an earlier video, you can think about division in two different ways. You can think about it as making groups of things like we did in the cat problem, where you had to make groups of 4 legs to figure out how many cats there were. But you can also think of division as sharing, figuring out how many things go in each group. Today we're going to do an example of each kind of division problem, one where the answer is how many groups, and another where the answer is how many things are in each group, to show you what I mean. Here's the first division problem. One year, I had 6 tables in my classroom. I also had 24 kids on my class list. I wanted to divide the kids equally between each table group so I'd have fair teams for games and stuff like that. How many kids would be able to sit at each table? Pause the video, grab a paper, and see if you can solve it. Then press play and we'll do it all together. So for this equation, we're trying to figure out how many kids fit in each group. We're trying to figure out how many in each group. We can use division to figure that out. Now I did a slightly tricky thing in that one where I told you how many groups I had, 6 table groups, before I told you how many kids I was splitting between the groups. When I write my plan, I'm actually going to put that in order. There were 24 kids, and I was dividing them into 6 groups. We needed to find out how many in each group. Let's see, let's use a K for kids this time. So, 24 kids divided into 6 groups equals the number of kids in each group. There's a few ways we could solve this. We could count by 6s till we get there. We could make groups. I think that's what I'll do. I'll draw some diagrams. So I'm going to make 6 groups. I'll label these, that these are the tables. And well, let's start passing out kids to each table. 1, 2, 3, 4. Okay, each table has 1 kid. All right, each table has 2 kids, and I've used up 2, 4, 6, 8, 10, 12 of the kids so far. I've got to keep going. There's still a bunch of kids who don't have a seat. All right, let's see, where are we now? 3, 6, 9, 12, 15, 18 kids have seats, but we're not there yet. We've still got some kids to put. All right, let's see if that did it. There's 4 kids at each table right now. 4, 8, 12, 16, 20, 24. Every kid has got a spot at a table group. Before I'm done, I need to label that the circles are kids, and I need to write my answer. K equals 4 kids at each group. Now, to help you hear and see the difference between a how many are in each group type of division problem and a how many groups type of division problem, I'm going to use the same situation with table groups and kids, but I'm going to tell it as a how many groups can I make problem. One year, I had 24 kids on my class list. I wanted to make table teams with 4 kids at each table group. How many groups could I make? So just like before, you're going to pause the video in a moment and solve this in your math journal. Now, the answer, you sort of already know it because it's a fact family with the last problem we did. But this will be more about how would you show your work for a problem where I have 24 kids and I'm trying to make groups of 4. How many groups could I have? Come back when you're ready to check your work with me. All right, so this time it's still the equation that starts with 24 and we're dividing it. But this time we're dividing by 4 because we're trying to make groups of 4. How many groups of 4 can we make out of 24? And the answer, this time it'll be G. G for groups. So for this one, I'm going to make groups of 4 kids. I'll label my circles as kids, and I'll label the bigger circle as a table. All right, so there's 4 kids, 8 kids, 12 kids, 16 kids, 20 kids, and 24 kids. So I made 1, 2, 3, 4, 5, 6 groups. G equals 6 groups. Now, looking at the work, it looks the same as when I solved the other problem. But the answer in some division problems is how many groups you can make. But in the other one, it was how many people would be in each group. Okay, so we just covered how in division story problems, sometimes the answer is how many groups in a grouping style problem. But sometimes the answer is how many are in each group in a sharing style problem. Now let's take a look at the pages in your Bridges book you've got to do this week. On page 148, it's all story problems. The last one is a challenge problem. It's a little more complicated, might have more than one step. The other page you need to do is page 152. 3 story problems and a little bit of money review, just to see how you're doing with that still. It sounds like it's time for me to go feed the kitty. So I will see you in the next one. Bye-bye now.